to find a certain area of the particular diagram. So the very first one I want us to look at will be our question number 1. Sorry. I don't know what's happening to my throat, but I'm very fine and fit. I hope you are all fine and doing well. So without wasting time, let's bring it to action. So our very first one will be this nice looking question. So question 1 for today will be this type of question. Okay, so if you have your notebook, you can also draw. My drawing is not perfect, but it should do justice. Okay, so yeah. Okay. Then we have here to be 112 meters. Now, under this question, they are saying we should look for we should look for the distance around. So A, the distance around the field. Okay? And then B, they are saying we should look for the area of the field, excluding the pond. So this question comes with a preamble that reads as, in the diagram below representing the field with a circular pond of diameter 14. So the field of circular pond, which has a diameter of 14 meters, will be this pond. Okay, so our question 2, which is under this particular topic, is saying that we should find the area for all this, excluding the pond, okay? Excluding the fishing pond, which I have indicated with the yellow arrow, okay? So excluding that pond, we should find the total area. So what it basically means is that when we are doing our area calculation, we will not have to include the pond. But in this case, the pond is part of the whole thing. So we'll have to find the area of the pond, and then when we are done, we'll subtract it from the total area of what we have there, which includes what? The field. Okay? So excluding the pond. Okay? So let me just write this to indicate that that is our pond. Okay, so that basically that's our point. Okay, so yeah, someone is saying good morning. Good morning to you too. It's great to have you. Okay, so let's look at the solutions. The very first one, they are saying the distance around the field. Now, distance around something is basically the perimeter of the thing. Okay, now when you look at this closely, this are semicircles. Okay, now that we have two semicircles, we can either bring those two separate semicircles together, and obviously they are going to form what? A circle. Okay, so solving this, we can use two different ways to find it. Now we need to break these sections into different parts so that it will be easy for us to find. We can't find the perimeter around the field just by basically doing everything together. We would have to find them separately, okay? So when we look at this closely, this is a semicircle. Now, perimeter basically means if Kofi is standing on this side, Kofi needs to walk around this field and come back to where he was initially standing at. Okay, that's the perimeter. So perimeter basically means that what? The distance around something. So if I say what is the perimeter of, or what's the perimeter around your house, it basically means that the distance around your house, if you have to walk from one point and back to that same point. Okay? So what we need to do now is to find the distance from this side where Kofi is to this side where Kofi will be now. And then we have to find the distance from here where Kofi is now, and then Kofi will walk to this side, and then come back to this. Okay? So when we look at it closely, we are looking at the circumference of this semicircle, and then we are looking at the circumference of this semicircle. Two semicircles will come together to give us a circle. Okay? And then they will all use the same diameter. Why am I saying diameter? Because the 56 that has been given to us here is actually the diameter of the circle. Okay? So someone wants to find out what this is. This is 14 meters. Okay? 14 meters. The pawn is 14 meters. Okay? So the diameter for the the semicircle will remain the same as the 56. Okay? So what we can do is either we can find the circumference of the semicircle, or we'll bring the two semicircles together to give us what? A circle, and then we'll find the circumference of that particular circle. So without wasting time, let's just spring into action and see how best we can solve this. Okay? So doing that, we've established that this is our diameter. From this side to this side is our diameter. Okay? It's not our radius. But let's establish the formula for finding the circumference of a circle. So circumference of a circle equal 2 pi r. Now, most students confuse this formula with pi r squared. Now, you know that area has its units having a square. So with these two formulas, the one that has a square in it belongs to area. So if you want to find the area of what? A circle, you use the formula that has the square, the r being squared. And then if you want to find the circumference of a circle, use the one that has the 2 pi r. There's no square in it. So this is the formula we are going to be concentrating on. What have I said so far? I've said that since this is a semicircle and this is also a semicircle, and then they have the same diameter, the same length here will be the length that is here. So it means they have the same diameter. Once they have the same diameter, it means we can bring those two semicircles together to form a circle. This is the circle we form with a diameter of 56 meters. Okay? So to find the distance from this side to this side, okay, and then the distance from this semicircle, one side to the other side of the semicircle, will basically means just joining the two semicircles to form a circle, and then we'll find the circumference of that circle by using this formula. Okay, so now our formula contains what we call radius, but we have been given diameter. To find radius, we know that diameter equals what? Twice the radius. Okay? So in order to find radius, it means that when you have diameter, you just have to divide it by 2. So that's the formula we are going to be using in order to get our radius from our diameter. Okay? So let's establish radius equals what? Diameter divided by 2. So it means our radius, which is 50, our diameter, which is 56, will be equal to what? Will be 56 over 2 in order to give us the radius. When we do our calculation, we'll get 28 meters. Okay, so it means our radius is 28 meters. Pi has been given to us to be 22 over 7. Okay, so pi is always 22 over 7. So we are going to fix that into our equation. This is going to give us 2 times 22 over 7 times what? 28. Remember, we are not looking for area, so you don't have to do 28 times 28. That formula is for just finding area, which I have indicated here. Okay? But we are just doing circumference. Circumference is the same as the perimeter of a given circle. Are we okay? So now that we've established that, we can quickly go ahead and then look for the distance around the circle, okay? The distance around the circular part, which is this. So calculating the circumference, we'll end up getting 28. 7 will go into itself 1. 7 will go here 4, okay? So 4 times will be 8. So this is going to give us 88 meters. So the circumference for this portion of the semicircle and this portion of the semicircle altogether is what? 88. Okay? So this is 80. This 2 is 88. Now, if Kofi walks from this side to this side, and then this side to this side has been covered to give us what? 88. Then all we need to do is to find this length and then this length. Now, these two lengths have been labeled. The top part has been labeled as 112 meters. It is the same length down here. So it means this one too is 112 meters. Okay? So all we need to do is to add this 112 meters of this side and then 112 meters of this side. And then we'll get our total distance around the shape. Okay? So we've established that this is our circumference for both semicircles. So it's going to be 112 plus what? 112. Remember the 112 is for this side and then this side. Then the circumference of these two semicircles, as we've calculated, is 88. So adding this will then now give us 400. Okay? So once we have that to be 400, okay? Once we have that to be 400, or wait, I'm coming. I want to check. So let's do the calculation so that we don't get anything wrong. So 88. This will give us, okay, it's not going to give us 400. This is supposed to give us 2. So we'll have 1 here. Okay. And then, yeah, that's going to give us 11. And then we'll have 1 here. This is going to give us 3. So 312, sorry. So this will give us 312, okay? Now, we've established that it gives us what? 312. Are we okay? We've established that it gives us what? 312. So we'll quickly then finalize it by adding our units to it, okay? We'll quickly finalize it by adding our units to it. Now, when we look at this closely, our circumference, when we look at it closely, we have to make sure that what we are doing is correct because we actually joined the two semicircles together. Joining the two semicircles together, let's just do a quick review. Joining the two semicircles together, we had our radius to be 28. Now, 28, when we do our calculation, this will give us 4. This will give us 8. So 88 times 8 times what? 22. So let's do that calculation and make sure we are doing the right thing. I was just guessing, so let's make sure we are doing the right thing. This, when we multiply this will give us 6. Oh, okay. So it's supposed to be 176, not 88. So it basically means that the 88 is just for one circumference of the circle, the semicircle. So it means that we would have to add an additional 88 here, and then we add an additional 88 here. So it means that the initial 400 was correct, so 400 meters, okay? If you are confused, let me redraw this, and then I'll just do an organized calculation for you. So this side was 112, and then the pawn has a diameter of 14 centimeters. And this one was 56 meters. Okay? Sorry, they are all meters. Now they are saying that we should find the area. And I've already explained from our previous slide that the area of the whole thing, except the pawn, that's the B. Now the A is saying that we should find the perimeter. And I've explained that the perimeter is just the distance around the thing. Okay? The distance around this whole thing. So if Kofi is here, and Kofi decides to go around this field and back to where he was standing initially. Now we have two semicircles. The two semicircles will have their diameter to be this 56, okay? So now these two semicircles, if I join them, I'm going to get a circle, and a circle with a diameter of 6. Now, if I have this, I'm going to use this formula, 2 pi r, okay? Now, 2 pi r because we are not doing it for just each or individual semicircles. We are doing it for what? All the semicircles coming together to form a circle. But if we are doing it for a semicircle, it's going to be half the 2 pi r, okay, which is going to give us pi r, okay? But we are not going to do it for that. We are going to do it for just the semicircles all together so that we don't have to do the calculations for one semicircle, and then I'll do a different calculation for another semicircle. So now that we've established that, all I was saying initially was that we've established this, but we need radius. And then to find radius is basically what? Diameter over 2. Okay, so if my diameter is 56, I'll just have to divide it by 2, and then I'll get 28. So it means my radius is 28. Fixing in my radius is going to be 2 pi times what? 28. Okay, 2 pi times 28. We've been given pi to be what? 22 over 7 in the previous question. In the question I stated, I'm just redoing it because there was some bit of confusion. So we have 2 times what? 22 over 7 times what? 28. And then this will go here 1, this will go here 4. This 4 will multiply 2 to give us 8. 8 times 22, this is where the confusion was. 22 and then 8, we'll get 6. And then this will give us 16. There's 1, so 17. 176. Okay? So 176 meters. So that's it for this. But if we are using just the single circumference or the individual circumferences, then it means you're going to get 88. It means that you would have to do 88 plus 88 plus the length you have up here. Okay? So now that we've established that this whole circle, which represents these two semicircles, is what? 176 meters. We can then go ahead to find this portion which Kofi will pass, and also this portion which Kofi will pass. Because it is a rectangle, it means that this length will be the same as this length over here. So we are going to add both 112 plus 112 for this side and this side. And we've already established that this one is 88, this is also 88. But if you do the joint calculation, you end up getting what? 176. So we'll just add 176 here. And then when we do our calculation, we'll get 400 meters. Now, don't forget the unit. The unit is very important. Now, the 400 meters represents the distance around the field. Now, we are going to look at the area, finding the area, which is what? Our B. And I'm going to change the marker to blue. Okay? So, finding the area, which is our B. First thing we need to do is to find the area for the two semicircles. Okay, we'll find the area for the two semicircles. So to find the area for the two semicircles, we are still using this circle. Okay, so let me draw the circle here nicely. I promise I'll try and draw a nice circle. So it still holds to have the diameter of what? 56 meters. Okay, so let's find the area for this side. This is the first one we are looking for. Then we'll find the area for what? This one. Then we'll find the area for the pond. And then we'll subtract the area of the pond from this whole thing after we've done the addition. Okay? So we have 56. 56. Let's look for the radius. Radius will be what? Diameter over 2, which will give us 28 meters, as we've established here already. Where is it? Here. Okay. Now, remember in our previous slide up here, I stated that to find area, it is pi r squared, not 2 pi r. So we are going to state that pi r squared. Okay? Now, in the question, they said we should take pi to be what? 22 over 7. Okay? So it's going to be 22 over 7 times what? 28 times what? 28. Okay? Having that, let's now carefully do our calculations so that we don't miss any step. Okay, so we want to carefully do our calculations. So to carefully do our calculations, all we need to do will be to basically multiply this. Now, we'll do this. This is 8, okay? But let's first of all get rid of this 7. So 7 will go here 1, 7 will go into 28 4 times. So we'll have 22 times 4 times what? 28. Okay? Now that we have this, all we need to do is to do this multiplication. Doing this multiplication will give us 88 times what? 28. Okay? We'll go ahead and do this calculation to get, let me see, I'm going to guess if I get it wrong, you just send the correct thing in the comment section, but I'm thinking it will be, okay, 8. Okay, so it's going to be 1, 2, 3, 2 meter square. Why meter square? Because we are dealing with what? Area. Okay, so please check the calculation. All you need to do this calculation for me, okay, and check and see if it tallies with the 1, 2, 3, 2 that I have done. I am monitoring your comments, so if you get it, you can just post it there and confirm so that we can move ahead. But then again, I'll move ahead. If you have any issues, we'll come back and then rectify that. Okay, so we are done with that. We were able to establish that these two semicircles, when they come together, will form a circle which has a diameter of what? 56, because this line here shows the diameter of a semicircle. Once we've established that, we've done our calculations to be able to get our radius, and we said if this is 56, we divide it into 2 to get our radius, which is 28, and then the formula says that pi r squared. So pi r squared, when we've established, or we've been given pi in our question to be 22 over 7. So if pi is 22 over 7, we fix it in, and then we do radius squared. Radius squared is the same as the same radius multiplying itself. So that's 22 times 22. And then we'll cancel the 7 and the 28. Sorry, 28 times 28. And we'll cancel the 7 and the 28. Once we do the cancellation and we solve, we should get this answer. I'm waiting for a feedback in the comment section as to whether this answer is correct. Okay? So once we have this, then we know that we are done with this part, which is the semicircles. Then we'll go to area 2, which is the rectangle. So this is the rectangle. This is the rectangle. Now, with the rectangle, we have one, 1, 2, and then what? 56. Okay? Yeah, someone sent a comment that it is 2, 4, 6, 4. Okay, so then I'm guessing that this will actually be times what? 2. Okay, so 2, 4, 6, 4. Okay, so it means that the total area for the semicircle 1, semicircle 2, when you do this calculations to give you 2, 4, 6, 4 meters. Okay, so this is what we are going to be working with, not this one. Then it means that this one is actually for one semicircle. Okay, so let's take note. Now let's look at the total area, which is area 2 for the rectangle. And then we have 56 and then what? 112. Thank you very much. Who was that? I think Rebecca. Thank you. So now let's concentrate on the rectangle, which is this area 2. Now with the area 2, when we do our calculations, we'll have 1, 1, 2. Area, as we know, is what? Length times what? Width. This is our width and this is our length. So we are going to just fix that in quickly. And then we'll have 56. And then when we do this calculation, so please try and do that calculation also for me. Okay, I don't want to waste time to go and do the calculation. So try and do the calculation for me. But then again, I'll also guess again. And then if it is, you just have to confirm it for me. So this, please do this calculation. 1, 1, 2, and then what times of 56. Okay, I would guess, should get something like 6,272. Okay. So this is what I'm guessing. Please confirm in the comment section so that if we have any issues, we can go back and rectify it as soon as possible. I'm doing this so that the class can be interactive, so that it won't be like you're just watching some lesson on YouTube. Okay? So I'm monitoring your comments, all those saying hi back to you. Let's try and do this calculation to check and see if this is correct or wrong. Okay? So that's for area 2, which I had, from just looking at it, I had 6272 meters squared. Okay, so I'll be waiting for your feedback. And then Once we are done, there's a third part of it, which is what? Area 3 we need to look at, which is the pond. Okay? So the pond came with a diameter, not a radius, of 14 meters. Now, as we've established, to find the area of something, it is pi r squared. Okay? Pi r squared would then give us, okay, so someone has confirmed, I think Rebecca has confirmed again that it is 6272. Okay, so awesome. So we can move on. So now let's move on to the area 3. Area 3, we had 14 to be our diameter. Then again, we realized that it's two things. You can have pi. Let me clean this. Let me not confuse anyone. So I'll not talk about that. So let's stick to the traditional formula, which is pi r squared. Now that we've established this pi r squared, we'll quickly just see how we can get our radius, okay? Because the diameter that has been given here is 14. Diameter equals 14. So in order to find the radius, it is diameter divided by 2. So this would be 14 divided by 2, okay? So 14 divided by 2 will give us 7, okay? So it means our radius we'll be working with will be 7. Awesome. Okay, so 7 meters. And obviously, in our previous question, as the question stated, pi is what? 22 over 7. Sometimes they can give the pi to you to be a decimal, which would be 3.14, blah, blah, blah. That's if they run it off, okay? So now that I've established that our radius is 7 meters, we can just fix that in quickly. So doing that will give us 22 over 7 times what? 7 times what? 7. Okay? Now this 7 will cancel this 7, so we'll have 22 times 7. Again, please, those doing the calculations, check 22 multiplied by 7. Let me see if I can guess. This should be easy. 154 meters. Okay. So then again, check and verify if this answer is correct quickly so that we can move on. So we have broken this into 3 parts. Why 3 parts? The first one was 2 semicircles, which we worked with. Okay? 2 different semicircles we worked with. We joined it so that to make our calculations easy. If you don't join it, then you end up getting this kind of answers where you have to do multiply it by 2 because there are 2 different semicircles. But when you join it, you go straight for it to get this answer. Once you get the answer, it means these 2 semicircles, you sorted them out. Once you sort that out, the next thing you need to do is to find the area for this. Let me use a different color. Okay, so I'll use purple. You have to find the area for this rectangle. Once we find the area for this rectangle, all we need to bring here, as in the answer is 154. Brendan, you have to state it, okay? So once we find the area for this rectangle, the next thing we need to do is to find the area for the pond. Why the pond? Because the question stated that we should find the area of the field excluding the pond. Now, excluding the pond basically means that when we add this area 1 and then this area 2, it will give us this full shape. Now we want to take this pond out of it. So we are going to add this area and this area, and then we are going to subtract it from this. Okay? So let me go to another screen, or let me find a place here. So let me do the calculations here so that we can do the referencing easy. Okay? So now area 1, which is the semicircles, both of the semicircles, plus area 2, which is the area for the rectangle. Okay, when you add all of them, you subtract what? Area 3 from it. And we've established that area 3 is our pond. Okay, so now let's do that calculations quickly. Now, when I add this 2, 4, 6, 4, okay, 2, 4, 6, 4, and then I add the area for the rectangle, which is what? 6, 2, 7, 2. This should give me 6, 3, 7, yeah, 8. Okay? This will give me 6, 3, 7, 8 meters. So this whole thing will be what? So please kindly check quickly and confirm if that answer is correct. Okay? And then we are supposed to subtract this from it. So it becomes that. So once we have that, all we need to do is to do our subtraction. When we do the subtraction, we should have 8, 5, 8, 2. Then again, please check this and make sure what we are getting is correct. I want us to have this interaction, so I don't want to just write the answers down and then just come and write it on the board for you. So I'm waiting, do the calculations quickly and confirm if this is correct. In less than 1 minute, let's do that. Those who want to copy this too, please copy it. It's very important for you to copy. Don't think that, oh, once it has been explained, I've understood it, so I don't need to copy. Please try and copy it into your notebook and then later date. But what I'll do is that I'll look for a similar question that I'm going to write on the next screen. So you have to just practice with it. Okay, so Josephine is saying it is 8736. Yeah, so it's the same thing. So now let's do the subtraction. What did you get, Josephine, for the subtraction? Josephine, what did you get for the subtraction? Okay, so yeah, that's Rebecca has replied with a subtraction, which is the same answer that we have here. So I think we are good to go. We are going to move to a similar question. And then at the end of the day, I'm going to give you similar questions to try on your own. It's not really compulsory to send me a feedback on those questions. But if you send an email, just like the way some people sent, they solved the previous questions we did and they sent an email. I replied them. So it's if you want to do that, that's fine by me. Now we have this. Please try and draw along. And then we have this also. Okay. We have this to be 6 centimeters. This place has been named as PSQR. And then we have this to be 21. This is not drawn to scale, so if it's crooked, please manage it, okay? If it's crooked, please manage it. So that's what we have. They are saying that we should find the perimeter. So the first thing they are saying we should find the perimeter. The second thing they are saying we should find the area. Remember, I've already explained how to find the perimeter of a figure. Okay, perimeter basically means what? Walking around that particular figure. Okay, so it means that if Kofi is standing here, Kofi should walk around this shape and back to the point he's standing. That will give us the perimeter. You should walk along the shape, not away from it. Okay, so that's the explanation of perimeter. So now to do this, you realize that when you look at this closely, when I break this shape down, let me use a different color marker. Let me use green. When I break this shape down, I'll end up getting the first one, which is the bottom of that shape, to be 6, and then this is what? 21. Okay? That's the bottom of it. And then I'll end up getting a semicircle. The semicircle is not that smooth, but pardon me. Now, the semicircle, as we explained in the previous question, we know how to find a semicircle. Finding a semicircle should be easy for us. Those who are joining us late, please, the lesson, once we are done, will be uploaded in the next 30 minutes. So if you missed anything, you can then go back and then watch it, okay? For Richard School students, this is a very important lesson as compared to the previous ones because we are prepping for our end of term. We are hoping that this pandemic would resolve soon. Those who are joining us on YouTube for the very first time, please go and subscribe to the channel. Why do you have to subscribe? Because anytime I would have to come live, it will get to a point I will not come and inform you or inform your parents. But if you are subscribed, you get a notification that Mr. Logoso is coming live so that you join as soon as possible without any delay. Okay, so try and then just hit the subscription button. Now, when we look at this shape has been divided into two parts. Okay, let's dive deep. So they are saying that we should find the perimeter. The first perimeter will be basically walking around this shape and then coming to work on this side. And then voila, you are done. We are not going to pass the middle, because if I say you should walk around your house, it doesn't mean that you're going to pass through your bedroom. No, you won't pass through your bedroom. So basically, this shape, if they say you should find the perimeter around, or the perimeter of this particular figure or shape, it's just walking around it. So you don't need to come and pass the middle here. Okay? This broken lines, you don't need to pass there, or you don't need to calculate or add it to your perimeter. So in order not to waste time, we've established that this is a rectangle, and this is what? A semicircle. Okay? Okay, so we are going to solve them separately. The formula for finding the semicircle, as I've already explained, for circle, it is what? 2 pi r. Okay? Now, half of that gives us what? A semicircle. These twos will cancel, so it means that the formula for finding the perimeter of a semicircle is pi r. Okay? It's pi r. Because half of 2 pi r gives you what? The semicircle. Okay, so let's not waste time. Those who want to draw, quickly draw that, and then we can continue. Okay, quickly draw that, and then we can continue. So in order to do so, all we need to do is to find the radius. Now, looking at this measurement is the same measurement that is at the broken line. So it means that this one is also 21. And then from this side to this side tells us that it is diameter. Okay? It is diameter. Now, to find radius using diameter basically means radius will be what? Diameter over 2. So if we have 21, it is going to be 21 divided by 2. Okay? 21 divided by 2. And that's going to give us a decimal. That's going to give us a decimal. And now it's going to be 10.5. I know most of you don't like working with decimals. So what you can do, if you don't like working with decimals, you can leave this as you see it. So you can fix it into the equation like that if you don't want to work with this. Okay? So we'll have pi r. Please take note, pi has been given to us to be 22 over 7. Okay? So pi r, and then we have our pi to be 22 over 7. And then we don't want to work with the decimals, but I think working with the decimals should be easy. Just that when you flip the dots, you get 105 over 10, and then that is a lot of calculation. So I would think you should use the 21 over 2. Okay? So that it will be easy. When you look at it closely, when you want to cancel diagonally, you realize that the 2 will do justice to the 22 and the 7 will do justice to the 21. So that makes it easy for you. So we'll have this 1, and this will be 3. This 1, this will be what? 11. So we'll have 11 times what? 3. The ones don't matter. Anything divided by 1 is that same thing. So it doesn't matter. Hi, Abiashi. Hi, Jody. Hi, Hilary. Okay, Hilary gave us the answer. Thank you very much. So this will give us 33 centimeters. Please, the unit is very, very important. The unit is very, very important. So we have 33 as what? The circumference of what? Just this. Just the circumference of what? The semicircle. Okay? So let's not confuse that. Now we'll go ahead and find this portion, which is just 6. And then we'll find this portion, which is what? 21. And then we'll find this portion, which is also 6, because it's just the opposite. And then the circumference, which we've established to be what? 33. Okay? So to do this calculation, all we need to do is to do this addition for this. And then if I am not mistaken, this should give us 66 centimeters. Please check for me. Okay. Okay, so Jason has also joined us with the mother's phone. Hi, Jason. So this will give us 66 centimeters. Okay. It's not a square because we are dealing with what? Perimeter. So let me write this here so that we don't forget, and then area. So we are now going to move to the second one, which will be the area. So we've established that the perimeter is 66 centimeters. I'm waiting for confirmation. Do the calculations with me so that it will be an interactive lesson. Tomorrow, don't forget, we'll be doing our Zoom lesson also, okay? This is just to help you. I know I'm doing all this because I know that math, if I leave you and I just send you questions, my brother and my sister, it will not work. We will come back to school and then your heads will be empty. That's why I'm going through all this pain to bring content to you. So please take part, take it serious, because at the end of the day, you are the one going to write your final exams. This goes to all students, not from Richard School. Okay, I know people are joining from different parts of Ghana. I had some nice WhatsApp chats with some students from different schools, some schools in Tema, some schools in Bron, all the way in Bron. I was very thrilled to speak to such students. Okay, so having all this, it means that we have 66. Now let's move to the area. The area too, we are going to use the same diagram I've drawn here. The same diagram. So we'll do for rectangle first, or we can do for semicircle first. So let me name the semicircle as my area 1, and then my area 2 as my rectangle. So let's do for area 1. Area 1, to find this area for a semicircle, we know that the area for a circle is pi r squared. That's for a circle. So if I have a circle, half of it becomes my semicircle. Okay? So if half of it, then it means half times pi r squared. That is the formula we are going to be using. So formula for semicircle is just slashing the formula into 2. How do you slash into 2? By multiplying it by a half. Okay? So that's what we've done here. And then we are going to go ahead, taking our pi to be 22/7. So half times what? 22/7 times, we've established our radius is what? 21/2. 21/2. Okay? So because we don't want to use the decimal form of 21/2 is 10.5. Most of you don't like using decimals. Let me hear you. If you think you like using decimals, say yes in the comment section. If you think you don't like using decimals, say no in the comment section. I'm watching now. But I know most of you don't like using decimals. That's why I'm saying that you should use the 21/2. Okay? So r squared means that 21/2 will be written twice. Okay? Don't worry about it. This whole thing will cancel out by itself. So I'm going to change the marker, and then we're going to do the calculations. Okay? So the first one, this 2 will give us 1, and it will go here to give us 11. This 7 will go to this to give us 3. Okay? Now this 2 cannot go into 21, so we'll leave it. This 2, there's no other 2 or divisible by 2 here that we can use. So let's just rewrite this whole thing. This will give us 1/1. We don't have to write that. So this will be 11. 11/1. We don't have to write a 1. Okay? But let's just write it so that we'll know that we are still dealing with fractions. This will be 3/2. And then this will be 21/2. Okay? So having that, if I do my calculations, this is going to be 33, let's simplify it, over 2 times 21/2. Please, this is not addition for you to go and do LCM over 2. This is basically multiplication. So numerator multiplies numerator, denominator multiplies denominator. So let's quickly do that. Now 33 multiplied by 21, let's do that calculation. This will give us 3, this will give us 3, this will give us 6, this will give us 6. So this will give us 3, 9, 6. Please check that calculation for us. 3, 9, 6. Okay, so it means that, and then the 2 times 2 give us 4. So 396 divided by 4. Okay, 396 divided by 4. Let's do that calculation quickly. So to do that calculation, basically, we'll end up getting, let me see, yeah. Okay, so it should give us 173.2, yeah, 0.25, yeah, 0.25 centimeter square. So that's it for our area for the circumference of this particular circle, okay? Area for the circumference of this particular circle we are trying to solve for. So yeah, basically that is it. So please check. Okay, I'm trying to read the comments, and someone is saying I've written. Okay, yeah, I get it. Thank you very much. It's supposed to be 396. Let me see. Let me go back and do the calculation again. 3 times 1 will give us 3. This will give us, that's 33. This will give us 6. And then this will also give us 6. Okay? This will be 3, 9. Yeah, this is 6. Oh, it's 21. We are multiplying by 21. Okay? But then again, this calculation is not really important, but you should have your final answer. It's the final answer I'm concerned about. But this should give us, because we are dividing with 4. Okay? If we were going to be dividing with 2, another way we could have solved it was just ignoring this half. Okay? So we could have done 22 over 7 times what? 21 over 2 times 21 over 2. All this divided by 2, because dividing it by 2 is the same as multiplying it by half. Okay? If you do it that way, all this should give us that, it should give us 346.5, yeah. And then over 2. Then it will bring us back to this calculation. But because we are getting this 2 and this 2, when we do this top multiplication, we'll get 693. And then when we do our calculation dividing it by 4, we'll get 173.25. Okay, so whichever multiplication style you use, or whichever way you want to present your formula, especially this one, will determine how your calculation will go, and it will also determine your final answer. But I think I got a confirmation from Rebecca that it's supposed to be 173.25 centimeters square. So it means we are on the right track. So that's just for area 1. Now area 2, this is our area 2, which is what? The rectangle. So let's quickly do that for the rectangle area 2. Area 2 is very simple. It's 6 times what? 21. Why? Because area of a rectangle is what? Length times what? Width. So we've established that. When we do our calculation, 6 times 21 should give us 126. I know people are now thinking, 6 times 21, 6 times 21. But it is 126 anyway. Please check quickly. Centimeter square. Let's not forget. Centimeter square. And then we'll have our area for that. Now, to find the total area for this figure, we've separated a semicircle and a rectangle. So all we need to do is to just add it back. So to give us a total area. Okay, so total area will be equal to 126 plus 173.25. To do that calculation, please, this one too, you should do it. Please, quickly. I don't know, maybe I think the lesson is not as fast as, because of the internet, it's not fast, so it's not on time. So your calculations don't get to me that early, okay? So try as much as possible to work fast for me. So doing this calculation, this one too, please do it and then confirm in the comment section. So 299, there's no decimal here, so 0.25. Yeah. Okay, so awesome. So this will be our final answer. If this was an objective question and you get answers like maybe 299.3, then you choose it because when you round this off, you get 299.3. But if it is just subjective, then you have to leave it this way. Okay? So basically, that is it for this particular question. I'm going to give you just 1 minute if you need to copy. Those who have phones and can do screenshots, just quickly do a screenshot so that it will serve as your lesson. Thank you, Delphina, for that feedback about the answer. It's good that you are making this lesson interactive as possible. Okay? So the next thing we want to look at will be your assignments relating to this particular topic. So I'm going to draw 2 of this type of questions. You're going to copy them, and then you're going to use it to practice. Okay? If you want to send me the final results of it, fine. Send it to my email, mathematicsbydominiclogosu@gmail.com, and then I'll check for you. Okay? So when I check for you, I'll try as much as possible to send a feedback to you. But then again, it's not a compulsory assignment that everyone should do. So if you want to do it, that's fine. So let me give you the So this one is similar to the very first one we did, but just that it doesn't have a pond in the middle. Okay? So whichever way you want to do it, if you want to do it my way, you can do that. If you want to do the individual calculations of the semicircle too, you can do that. This place is 14 centimeters, and this place is 25 centimeters. The first one is you should find the A. Find the perimeter. And then B. Find the area. So with this one, there's no pond in the middle, so you don't have to do any calculations. Please take note that the 14 is the diameter, and then the 25 will only be related to the rectangle. So that's the question 1. The question 2, we are not ending. There's another topic I want us to look at quickly. So please stay tuned. We'll look at that topic and then we'll call it a day. So we are not ending. Those who are thinking of going off, don't go off because this is your prep exam question. Okay? So the second one, you have this. My drawing, dear, please forgive me, pardon me. The drawing is terrible, but you should. Okay. So let me change the color so that to make the visibility great. So this will be 21 meters. This is 9. And then this is 6 meters. Sorry, it's meters, not centimeters. If I do centimeters and meters, some of you will not survive. So let me just do meters. Then again, if you go and then it's centimeters and meters, you just have to change the meters to centimeters and then you use it to do your calculations, okay? And then, so I'm not going to write for this part because this is 21 and it applies for all of them. But all I need to do is to give 20 meters over here. So that's the shape. This one, they are saying that find A, the perimeter. If you've subscribed to the channel, please say hi. If you have subscribed to the channel, say hi in the comment section because I want to look at it and see if possible if I can give coupon codes for free quizzes on Think Academics. So if you have subscribed to the channel, please say hi. And before I give the coupon code, I'll go and check. Okay, I'll go and check and make sure you are a subscriber to the channel before I'll hand out the coupon code. Okay, so if you have subscribed, you are watching me and you've subscribed to the channel, say hi in the comment section. If you have not subscribed and you still want the coupon code to enjoy a free course on Think Academics, subscribe and then you say the hi. Find the area excluding. What am I writing? Excluding the shaded region. Okay, so people are, I think I have subscribers now. That's great. That's the only way you can thank me for doing all this. Because the amount of data and then the tools I have to use to do this, you don't really want to know. I've spent a lot of money to bring this to you. So the smallest way you can do that, help me out is by subscribing. Thank you very much for subscribing. Now, today we want to, our second topic for today, we were supposed to do 3 topics, but let's look at the time and how far we can go. The reason why I want us to do all the 3 topics is that this lesson will be uploaded on YouTube. So anytime you are bored or you're going to write an exam and you want a quick tutorial to prepare yourself, this one you don't have to go back to the textbook. So you just come here, watch all the videos, and then you know that, oh, you've revised, and then you write your exam. Now, I want to look at another topic which is related to, I'm trying to get a topic. Where did I write it? So that topic basically is an interesting topic I want us to look at. Okay? It's an interesting topic I want us to look at. Can I add one last one? Okay, it's fine. Okay, which is related to change of subject. I'm sure most of you will be saying, yeah, we said it. Change of subject is related to change of subject. Okay, so I'm hoping by now most of you have drawn this. If you've not drawn this, you can come back and then watch the video and get the questions from it. So I'll have to move quickly to the next screen. Okay, so I'm moving. Okay, so change of subject. Now, one thing about change of subject is I'm going to use this opportunity to re-explain into details all the rules or all the things you need to know. Once you get comfortable with the things you need to know, all you need to do is to apply those rules. Okay, so those who are going off, they better come back because this is a one-time thing. But then again, this will be uploaded, so you will not have an issue. So let's get this interesting question. They are saying that make W or W, as the Montessori students will say, W, the subject of 1 over Y equal A over X plus B over W, or W, the Montessori students. If you went to a Montessori school, please say yes in the comment section so that I'll know the kind of students I'm dealing with. Yeah. Okay, so now let's look at this. They are saying we should make W the subject. Did I say W? Yes, I did. So this is our W that we need to make the subject. Look at where W is carefully. Then when you are done locating your subject, which is W or W, okay? W, Montessori students. I went to side 2, that's fine. So which is there, look at where it is. Now you go back and check the whole thing. Is there an expression? Obviously, it won't be an expression because most change of subject questions, they involve equations. What kind of equations? Linear equations. So the way we solve our linear equations is the same way we have to do our change of subject. So what are some of the rules we need to take note of? Moving when the thing is adding and you need to move it to the other side of the equal sign, it becomes negative. When it is multiplying and you need to move it across, it becomes what? Division. That's the two fundamental rules of change of subject you need to take note of. Okay? The other fundamental rule of change of subject you also need to take note of will be if there's a square. You get rid of the square by using what? A square root. These are the three fundamental things you need to take note of. That's all. Okay? And then the other one is general knowledge of how to solve linear equations. So with this one, we look at it closely and they say it's a linear equation. Obviously, linear equations with fractions in them, okay, you need to find LCM. So that brings us closer to the confusion or what has been causing you people not to like change of subject. Well, you need to find LCM and you have variables as your denominators. All you need to do is to bring all those variables together, okay? How did I know that we need to find LCM in this particular linear equations? Because we have denominators in this linear equation. Why am I calling it an equation? I'm calling it an equation because of the equal sign. Okay? So once we have denominators in the equation, it means you need to find LCM in order to do this. So what will be our LCM? As I've already established, our LCM, when you have variables throughout, your LCM is going to be just bringing all the variables together. Let me give an example here. If I have 1 over 2 equals 2 over A plus 3 over B. If I want to find the LCM for this, the LCM of this is going to be just bringing the whole thing together. Okay? If I have 3 over 6 equal 11 over M plus 1 over 2. All I need to do is to bring the LCMs together. But when you look at it closely, the LCM for 6 and 2 should be 6. So with that, when you have two numbers as denominators, you find their LCM. Then when you are done finding the LCM, all you need to do is to join the variable to it. So this will give us 6M. So this will be our LCM. Instead of doing it 6M2, no, it is not acceptable. So with this one, when you have two numbers and a variable, you find the LCM for those two numbers, and then you just join the variable to it. So this is our correct what? LCM. And then this is our wrong LCM. Then again, some people can actually use this, and then they'll arrive at their final answer. But I doubt if they are going to give you marks for the methodology. Okay? So please, let's take note of that. So this is my LCM for this beautiful equation that they are saying I should make W the subject. Okay? Good. So to do that, all we need to do is now take this LCM and use it to multiply the individual terms in this equation. But before we do that, we need to know the number of terms we have in this equation. So I'm going to quickly use this opportunity to explain how to discover or know the number of terms you have in an equation. Okay? So as I'm saying, this is a one-time lesson. Now, if any time you think that you are not, what have I written? Oh, that's interesting. Anytime you feel you are not so comfortable with change of subject, all you need to do is to come and watch this lesson, and then you'll be okay. So now how do we count the number of terms in an equation? Let me quickly go over that. If I have A plus B equals C, the number of terms is actually determined by the separation of equal sign, addition, and subtraction. Multiplication and division will not change the number of terms you have in an equation. Okay, so when we look at this closely, yes, we have addition separating it, and then we have what? Equal sign separating it. So this will be 1, 2, 3. So we have 3 terms. Okay, let's look at this. This 2 plus B equals C. Does it mean that this one will have 2 terms because of the addition? No. Why? Because brackets the brackets that have been introduced here shows that we actually have this to be 1. The multiplication, which is as a result of the bracket, makes this whole thing as 1 term. Okay? So this would be 1 term, and then because of the equal sign, this would be another term. So in this, comparing it to the top one, this is just 2 terms. Okay? So when you have brackets in it, the brackets changes that different terms that have been put into a bracket and make it as 1. Are we okay? So basically, that is the way to identify if it is it's 2 terms, 3 terms, or 4 terms. Okay? Let me write an interesting one here. If I have 2 into bracket a minus b minus 2b plus into bracket 4 minus a equals 6. How many terms do you think I have? If you have the answer to that, please write it in the comment section below. Write it in the comment section below. The top chart, you see somewhere they've written top chart. Some of you are already writing there. So write there if you think you know. Everyone should write something there. Count the number of terms we have in this particular yellow box. Okay, count the number of terms and then write it in the comment section below. Okay, without wasting time, let's move on to our calculation. So our calculation, we've established that this is our LCM. We've established that we have 1, 2, 3 number of terms. Okay, so if you have 1, 2, 3 number of terms, then it basically means that what? This LCM, we are going to use it to multiply 3 terms in this particular equation that we are supposed to make W the subjects. Okay, so I'm going to bring this here so that I don't waste the blackboard. So I have my question to be y 1 over y equal a over x plus b over w. Okay, so having this, we've established that LCM equal yxw. The operation sign between the b over w or w and the yxw is multiplication because of the brackets. Okay, so if you make a mistake with that, you can actually write it behind it. It doesn't really matter. It's not really compulsory that it should be in front of it. Now that we have this, let me change the marker quickly. Okay, so we are going to cancel. The goal is to get rid of the denominator so that we have a simple linear equation, then we can move things around. Okay? Yeah, so we can move things around. Those who are commenting out, get back to you. I don't want to say that, yes, that's the answer for other people to be discouraged to send their answers. So I'll get back to. So this will cancel. This will cancel. So we have Johnson joining us. Johnson, how are you? So basically that is it. Now we've done the cancellation. We want to go ahead and then rewrite whatever is left. Okay? So this is what is left times 1. We'll not really change it. So we can just forget about the 1. And then we have y, w, and a. So a, w, y. Whichever way you want to write it, it's multiplication that is between them, so it doesn't really matter. And then we will have b, y, x. Okay? So this is what is left of this equation that we have. Okay? Now they are saying that, let me rewrite this so that it doesn't look confusing. Okay? Now they are saying that we should make W the subject. But we have a situation here. When you look at this closely, you realize that we have W here and then we have W here. If we have W at both sides, then what should I do? I can't just say, okay, I'm going to make this W the subject and forget about this W. No, I can't do that. I have to actually make sure all the W's are filtered out, and then I make all of them the subject. There's only one way to do that. The first way is that we need to group our like terms. Okay, so grouping our like terms, basically, we are So far, only 6 people have responded to the question in the yellow box. How many terms is that? I'm waiting. I'm expecting everyone to respond. I have 23 students on the live view. I'm expecting everyone to respond. Okay? So, having that, we are going to group like terms. The only like terms we have is the one that has the W. That's what we are interested in. We are not interested in Y. We are not interested in X. We are interested in W. So, we are going to group like terms for W. Okay, so grouping like terms for W or W is this. This is positive. So, when it comes to this, it's going to subtract A, W, Y equal, then this will be left alone. So, B, Y, X. Then we have to do what we call factorization. So factor out. Okay, factorization. Now with factorization, what it means is that identify what you want. Once it's at both terms or both sides of this particular term, the one that's on your left-hand side after you've done the grouping like terms, fish out that or factor out that. So this is what we are interested in. So you're going to bring it out. It basically means that when I bring this out, what will be left on both terms? So W coming out, X will be left because when I take W from that side, X is left. Why do I keep saying W? Montessori students. Okay. Then I have minus, when I take this W out, which is what is here, it will be what? A, Y. You have to do this in such a way that when you expand back, you should get the same thing. Now, when you look at it carefully, if I should expand this W into brackets X minus AY, I should get double X W minus what? AWY. Okay? So it means when you check it like that, you know that, yes, your answer is correct. Those watching me for the first time or those who have not subscribed to the channel, please do so. It's very, very important so that you don't have to go to your parents anytime to check and see if a lesson will be happening. Once you subscribe and you turn on the notification bell, anytime I'm coming live, you will know. Because it's not every day that I'll be coming live. I also do video tutorials for other students from other schools. So students from richer school who have not subscribed to the channel, sometime when I'm doing that video tutorial, you can sneak in once you get a notification. So do the subscription so that I don't miss out on anything. So we have BYX, okay? Now that we've done the factorization, you realize that this 2W now has become 1. When you look at it carefully, this 2W's now has become 1. And then all we need to do is to get rid of this into brackets X minus AY. So to get rid of that, basically, you can do the traditional class 1 algebra where we divide both sides by what we don't want. Okay, so we don't want X minus AY. So we divide both sides by that. You can still maintain the bracket. It won't change anything. You can decide to remove it. It will also not change anything. So we cancel out. Let me bring this here. When we cancel out, we then have an answer, which would be W equal BYX over X minus AY. And voila. Now, if this is an objective question, you shouldn't be worried about the top. This can be written as YXB over negative AY plus what? X. It's the same thing. I know some of you, when you are solving, you get something like this. This can also be written as XYB over. Okay, so it's also the same thing, basically. So basically, this is what we have. And then once we have this, that's our final answer. Now, your final answer, as I said, if it's an objective question, will determine the possible answers you have. So when you look at it closely, you should be able to determine whether it is correct or wrong. For instance, they can have the following as their answers, okay, in the objective question. Let's see here. X plus AY, okay. And then the c, let me write bxy over. Okay, let me change it. Let me add a little twist to it. So minus ay plus x. And then they can have x plus ay. So I'm going to explain why they will even make possible answers like this. Now, they'll make possible answers like this because it is possible that someone will forget to add the x here. Okay? They'll make possible answers like this because it is possible someone will forget the x and will also forget that when we do the other side, it's supposed to become what? Negative. And then they'll also make it like this because someone would think that because the person had x minus ay, then it's obviously going to be Oreku, hi, because I nearly asked who it was. You are welcome. This is your first time, so subscribe to the channel, okay? So having this, someone would think that, okay, because negative ay is starting, so this is wrong. But when you look at this closely, this answer, when I just bring the negative ay, remember that the negative belongs to the ay. So if you are interchanging, then it goes for it, and then the x is positive. So it's the same thing as we introduced here. And then someone will also get this answer because the person will forget that sending this AWY to this side should become negative, and the person will still write it as what? Positive. Okay? So that's how come they'll give you these possible answers to suit everyone's answer. Okay? So sometimes you do your calculations and you realize that, I got the answer. But when I solved it, I got the answer. But why was I marked wrong? Because you forgot to do something. And it is our duty as examiners or teachers to provide the wrong answers as well as provide the correct answers in exams so that everyone can get the chance or the opportunity to choose an answer. We don't want a situation where you do the calculation and you will not get your answer there. Okay? So that's the main goal. So you have to be careful when you are solving this kind of equation. So basically that brings us to the end of change of subject. I'm going to put 3 change of subject questions on the board. You're going to try them out for me. And then before I do that, I want to do a change of subject that actually involves square roots and squares so that we can bring this phobia about change of subjects to an end. Okay, so I'm going to move to the next board, the next blackboard. And then I have this beautiful change of subject question I wrote in one of the books. Let me check quickly, and then we'll see. Okay, so where is it? Okay, so I have this beautiful change of subject question. Capital X equal pi into brackets w or w square minus r square. And then the question says make r the subject. Who is scared to solve this? You shouldn't be scared. It's the same principle that we use, okay? So you shouldn't be scared about it. Now I want to explain something. Anytime you have something like this, first thing, as I said in this lesson, I told you that first thing, identify the subject, what you are supposed to make the subject is. And if you want to identify, that's R. Look at the subject carefully. It is not just R, right? It's R squared. So it means that when you even get it to be R, you have to get rid of the square. So which means that at some point you'll be applying a square root in order to get rid of that square. Okay? Now look at the general structure of the equation. You know that it's an equation because there's an equal sign here. Okay? So look at the general structure of that particular equation. And then look at where R is and look at how you can get rid of all the things around R so that R will stand on its own. Because that's the goal of change of subjects. Let me write the R well because it looks funny. Let me clean it right over. So that's the general goal for change of subjects, to get rid of everything around the subject so that the subject can stand on its own. Okay? So having this, when we look at it closely, it's like there's a bracket. The R is in a bracket. So we assume that the R is in jail. So we have to jailbreak the R. Jailbreaking the R, I think those who play PS and the rest, they know what jailbreaking is. Then again, it is not the right thing to do. You have to buy the CDs anyway. So having that, it means that we are going to do some form of expanding by using this pi to multiply, to expand so that R will be set free. Don't worry about adding pi to R squared because already you want R to be on its own. And why do I have to add pi to it? When you add R, the pi to the R, it will be easy for you to get rid of it because at that time R would have been jailbroken. Okay? So let's do that quickly. So we are going to expand. This one, you don't need to find LCM. You don't need to count the number of terms because we don't have any denominator in this particular equation. Okay? So this one is just a simple linear equation. It's just that there are a lot of things around it that we need to get rid of. So doing that, it means that it's going to be pi w squared minus pi r squared. And we know pi r squared. What is pi r squared? Area of a circle. But that's not what we are doing now. Okay? But that's what part of the things we looked at today. That's why I'm mentioning it. Okay? So then again, our focus should still be on this side of the equation. So it means we have to make sure we get rid of this. But before we do anything like that, take note. The r is negative pi r squared. We don't want to work with a negative. Again, if you want to work with a negative, fine, you can do that. But I would prefer to send the negative pi r squared to where x is and break x to where the negative pi r squared is now. Okay? To make things easy for me so that my r will not end up being a negative. Okay? So instead of taking pi w squared to the x, I'll rather take the negative pi r squared to where x is and bring x to this side. Okay, so this will be the change, and this one will go this way. So that this pi r squared, which is negative, pi r squared, which is negative, will now become positive, and then we can get rid of it, or we can stop it from becoming what? A negative. So I'll do just that by writing pi r squared. Now remember, it is no more negative because it has crossed the equal sign. That's the main goal or the purpose for which we are doing this. Pi w squared. The x is coming. The x is positive. So when it comes here, minus capital X. Please, when the thing is capital, ensure that throughout your calculations, you maintain its structure as a capital letter or variable. Do not change it and start writing small letters, okay? Now that we've established that, the next thing we need to get rid of is this pi. So it basically means that we are going to be dividing both sides by pi. Now this is the key. Here's the key. Dividing both sides by pi doesn't mean I'm going to divide this pi by just this. No. It's supposed to be divided by all this on this side of the equation. Okay? So let me rewrite this. Pi w squared x. Then I'll divide both sides by pi. Remember, it's supposed to divide everything on that side, not just one part or one term on that side, but every term on that side. Okay? Then I'll go ahead to do my cancellation. So I'll cancel pi. I don't have to be tempted to cancel this pi and this pi. I'll be explaining that at the latter part of this particular question. So don't be in a hurry to do some form of cancellation. Then again, your instruction is to make R the subject. It didn't say you should simplify anything on any side of the equation. So you don't be in a hurry to cancel this pi and this pi. Please, no. Okay? So now that we've done that, let's rewrite this nicely. And rewriting this, we'll get r squared equals pi w squared minus s all over what? Pi. Please don't be bothered about those two pi's that you are tempted to cancel. Once you do anything like that, you are going to be getting the answer wrong. I'll explain the reason why. Now we have r squared. R squared is not the same as r. So we need to do something in order to get rid of the square. And at the beginning of this particular lesson, I stated that when I have a square and I want a. All I need to do is to what? Bring what? A square root to cancel a. Why a square root? Because when I have root of a or square root of a, it basically means a raised to the power half. Okay? So if I have a squared and I'm introducing a square root, this, if I don't want to use a symbol, mathematically means what? Square. And then I've introduced a half, which will be a multiplication between them. So this 2 will cancel this 2, and then now we'll have a. So that's the purpose for which, or the reason why we introduce a square root, because a square root is actually a number raised to the power half. And then if you have a square, that is 2. 2 times 1 over 2 will give us 1. And anything raised to the power 1 is that same thing. So that's how come we introduce a square root. Okay? So we are going to introduce a square root for both sides of what? The equation. So introducing a square root. Now here's the key. If you are introducing a square root and the thing is a fraction, do not go and write this. Don't do this. The square root needs to cover the whole thing. So this will be wrong. But if you write it this, a over b, and then it covers the whole thing, that is correct. Don't go and do this. Maybe the thing is a long, and don't go and do this. Oh, it has covered all the equation, and then you end here. No, it has to extend to cover everything. Okay? So that's what we are going to do. We are going to make sure it covers the numerator and the denominator, and it covers all the terms in that particular side of the equation. So we've done that, and then now we can do our cancellation. Now doing our cancellation, we'll have r squared, and then we'll have this pi w square x squared over this. Are we okay? So basically that is it for our answer. The reason why I was saying that do not cancel out is that if I have a, b minus c all over a, even though I have a and a, it doesn't mean that this a belongs to this only. Okay, so if I want to really do cancellation, this is the meaning of it. So once I do this cancellation, it means you are going to be cheating what? C. It means C is not going to get A as a denominator. So that's why I always advise that do not be in a hurry to do some form of cancellation to simplify your work. With change of subject, we always say that the goal is to make the thing the subject. No matter how the other side is looking like, we don't really care about it. Okay? Unless, of course, maybe you are solving an objective question and then the possible answers demand that it's supposed to be in a simple form. Okay? So that brings us to the end of this particular lesson. I want to put some change of subject questions on the board for you to try out.